Great that you could make it due to heavy traffic to the Production Forum. I'm very happy to say a very warm welcome to the panelists today. Just on my right side, Dieter Manz, founder of Manz Automation AG in Germany, one of the most innovative drivers for decades within this industry, with a special focus on the CIGS fab solution as well as on new production equipment, up-to-date production equipment. We will learn during my panel. Then Peter Tinner from Oerlikon. He's with Oerlikon 29 years, so also very long related to that company and very long related to the PV industry as well. We will learn about Oerlikon's different technologies. Dr. Peter Fahrt is Chief Technical Officer of Centrotherm Photovoltaics AG, also 70 years, very long period related to that industry, holds a lot of IP and patents, and co-founder of Centrotherm's 100% subsidiary GP Solar. Very welcome, Peter Fahrt. Then we have Charles Gay with us. He's the president of Applied Solar and chairman for the Applied Solar Council. He's also kind of industry veteran for 30 years now within the PV industry. So we are very happy to have him with us and to learn about the latest developments within the crystalline PV world. And last but not least, Peter Pauli, he's CEO from Meyer Burger Swiss Solar Systems. So let's directly start with interesting questions. We had some introductions during this morning regarding current market development. I'm wondering, and I would like to start, let's have a look at the cell manufacturing capacity and the global demand. So we see this expected dip in 2012. I think everybody along the PV value chain was a little bit hit hard that tough times started already this year. And outlook is also very competitive with a dip in demand. And what we see here is that the top 10 players on the cell level are covering more or less 90% of the global demand expected for 2012. So I would like to start discussing, is the major scale-up an inevitable prerequisite to drive down cost and prevail? What are the strategies and what are your learnings in regard of many customer talks to banks? So Dieter, maybe you can comment on that. How can we, or how are you analyzing this current situation?
So actually we see the current situation as this. A lot of capacity is built up in the last year, mostly by the big Chinese players. And I think they have not really been aware about the market situation, especially in Europe and in Germany. So there was a lot of capacity coming up in the last year. So now all of a sudden, a lot of the big players, they recognize that really the German market is not as big as they expected in the European market. So there is a slowdown definitely there. And we have overcapacity in the market. But on the other hand, I think this is what is somehow necessary for the PV market to really become a mature market, to really drive down costs. There is a very competitive market right now. There's a lot of pressure on cost, but this brings, on the other hand, open much bigger global markets so that the demand will go up later on again. And we also think there's a lot of capacity will be obsolete in the next couple of years. Of course, a lot of the capacity that is built up is on old technology that have to be upgraded and replaced over the next year. So I think, at least for the equipment industry, there will be some really bad time coming in the next couple of months. So the revenues will definitely drop for expansions, but there is potential for retrofits, there is expansion for future business and long term.
Thanks, Peter. How are you analyzing this current situation, maybe from a perspective of a thin manufacturer or provider?
Yes. Okay. Yes, we see it quite similar. I mean, there will be an overcapacity now. which of course under other technology will be under pressure, because if some major players are not earning so much money anymore, they will wait a little bit longer until they invest in some other technology. However, we believe strongly on the thin film silicon technology due to the fact that we see a kind of leveling out of recent crystalline production costs. I mean, if you compare figures from Trina or Jinli over the last 2-3 years, there were not big movement in reduction of the cost. You see general maybe selling prices now in the $1.20, I guess, or even less. However, to achieve the cost, if you look on some potential, thin film silicon has a very big potential to be there much lower, maybe in the 70 cents, dollar cents, and therefore we see a good opportunity for us for the future for lowering the cost in the production.
Thanks, Peter. Peter from Central Term, coming back to this last slide, so maybe the analysts are wrong, or we will see bigger growth in the future. I know you're very well informed and have a lot of insight into the downstream channels as well. I see another option that the companies that do not ramp up will be shakeout victims, so they must ramp out to achieve cost efficiency. So ramp up is a kind of precondition in order to be competitive. Maybe I see another option that the equipment suppliers do a very well job, and the technology is improving against the background of high competitive pressure. You really just need always the most updated equipment, or in option 4, maybe PVs on the verge of competitiveness, and new players enter that market, and that's why we have seen so many ramp up during the last 24 months. Maybe you can comment on that.
First of all, it's what was already said, that we have roughly 1,000 production lines in cell production in the world, and according to our analysis, 25 to 30% of those capacities is outdated. Especially in a downturn, the industry is very much pushing into high quality products, high efficiency products, and those outdated lines, they're not useful anymore. And actually, during this conference, first day, Monday, we had several meetings with Chinese and Asian providers who are saying we have this factory capacity and we have this building, and we want to kick out the old production lines and put in new production lines. So they're using this downturn to improve their technology portfolio. And what we also have to keep in mind, what Mr. Manz was saying, is that given the reduction of prices now in this industry, this opens the door for new markets. We should not only look at the Asian market, Taiwan, Korea, India. There are new markets, emerging markets, which are getting relevant, and those people are getting aware of the, I call it cheap solar, this cheap solar energy. And for example, in our case, we recently acquired a big project in Algeria, North Africa, where people are buying a fully integrated factory from wafer cell module. And you ask them, is your intent to compete with the Chinese big players? And they told us no. We will use those modules in our own market in Algeria and perhaps North Africa, and we don't care in principle about competition out of China. So also, my key message is there's a lot of opportunities for machine makers if you did your homework in technology provision, upgrading of production lines, retrofit of machines, kicking out old production lines, putting in new, and also in emerging markets, which is mostly driven by, I call it, cheap solar.
Thanks, Peter. Charlie, one question. Why are we seeing such a strong ramp up in 2011? What is your view on that?
Well, I like to think that our customers are visionary, that they see that solar isn't cheap, it's competitive. It's capable of delivering low-cost electricity to a lot of markets. And the awareness of markets that don't require subsidies has taken hold here as the costs have come down. So you can kind of think of traditional way of looking at the market is it a feed-in tariff business or not? And the reality is today's market not only is feed-in tariff, but it includes government policies that encourage the development of renewable portfolio standards, renewable electricity standards, that include a significant fraction of the supply of new energy to come from clean energy, from solar and other sources. Between 2010 and 2020, the world's going to go from needing the existing 4,000 gigawatts of generating capacity to 6,000. So there's a 2,000 gigawatt opportunity in this decade, and solar today is at a cost position that over the course of the decade will be able to serve any new need by the end of the decade anywhere that people need new electricity. The electricity markets that are available now, costs have come down to less than $1 a watt and will continue to come down. This means that the long-term view that solar has had of providing distributed generation in rural electrification, as well as for developed countries where end-of-feeder lines, substation upgrades can be deferred by deploying distributed generation, making the grid stronger, is already cost-effective. Being able to serve in competition with diesels, which costs around 50 cents a kilowatt hour or more, is easy for solar to win in those markets. And there are a number of novel markets that are opening up because of the availability of investment among aggregators of carbon credits. Japan is a signatory to the Kyoto Protocol. Japan is now converting most of its generating capability from nuclear over to gas. And burning fossil energy means that the capitalization, the liquidity of those carbon credit funds is increasing in a way that even in places with high interest rates like India, photovoltaics can provide a return on investment at today's market value on the order of 15% or more. The way that our customers are leveraging their existing equipment base is to upgrade that equipment base. They're adding the capabilities that build on top of the foundations that they've already invested in to improve efficiency, because efficiency holds the key to leveraging the reduction in the balance of systems costs. In places like India, balance of systems are around 80 cents a watt. With a selling price today, you can easily find a module for $1.10, $1.20 a watt, depending on how good a negotiator you are. You can find an installed system at $2 a watt. At $2 a watt, in most sunny places on planet Earth with reasonable interest rates, we're less than 10 cents a kilowatt hour. This is a goal that we've been working for the last 35 years, and something that we can do now to see the markets grow. And the companies that you had on the chart, the first chart, are, I think, among those who see that there's a market here that is not just a feed-in tariff market, but a market that can be grounded in real-world, unsubsidized, unincentivized needs that meet this growing demand for more electricity.
Thanks, Charlie. Peter, from your point of view, what are the main sales drivers? We learned in the morning that the first companies went bankrupt, maybe a few more follows. Is this making banks nervous? How do you see your sales arguments regarding updated production equipment? What is your feedback from the customer point of view?
For sure, in this period we see several companies struggling heavily, but it is also a result out of the growth we had, and I think it was already 2-3 years ago very obvious that we will enter a consolidation period. We are now in this consolidation period. There are companies struggling heavily, going out of the business, and not mainly because of a bad market. It is also because of bad management, for example. So there is no reason why it should stop. It's a matter of awareness. Bankers are normally very nervous because the stock prices go down. they are short-term driven. We have to see that we are more mid, long-term driven and believe in the future and do for the future.
Peter, we learned that only state-of-the-art equipment allows cost-efficient and high-performance production. You recently have done reasonable steps in the area of selected emitter technology. Maybe you can give us some insights how that is improving cost structures.
I think this is the overall challenge right now of the industry, that there is a very high pressure to the markets. There is a very high pressure on the selling prices, but the good news is there's a lot of room for future improvement in manufacturing costs. As there is also, if you really look at the solar industry, it's maybe one of the very first times that there's really pressure on the market. Before there was always a very heavily subsidized market, so the pressure to reduce costs was not that high, so there was not that much effort in improving production technology, and this is now changing. And this is on the end good for the industry, this is good for the equipment industry. So in our case, we put a lot of effort in developing efficiency increasing technologies like the selective emitter you mentioned, where we have a very simple laser process that will allow us to very easily integrate selective emitter technology into existing lines and can increase efficiency levels on 0.3, 0.5% on the multicrystalline and also monocrystalline silicon solar cells, which is a lot, which can help really to bring existing production lines that are not really profitable back to some period of profitability. Maybe this will not be forever. These lines also have to be replaced after a certain time, but at least it can help to ease the situation in the short term. In the long term, we also think there have to be other technologies coming up. This is why we are very heavily investing into the CIGS thin-film technology, where we really have seen very good results. Recently, we have this, on this show here, a world record module that we demonstrated was just done 2 weeks ago on a world record level of 14% module efficiency, which comes very close to multicrystalline level. This was done on a real production line at Good Solar. And this really shows also the potential of these newer technologies, that they are really becoming mature now, and they really can help to really be competitive on the long term in the solar market, and really can help to make this industry much bigger.
Thanks, Dieter. There is a bright outlook for CIGS technology, and you're referring to your CIGS fab solution. From Oerlikon's perspective, Peter, how are you arguing while communicating with the potential customers? We learn maybe there are some ramp-ups in new markets, emerging markets, on side sales of turnkey solutions. On the other side, there are quite a few bad news regarding amorphous silicon and even regarding micromorph. A lot of press releases shouting out that this technology is almost dead due to problems with efficiency. I know that Oerlikon made some efforts to achieve the 2-digit efficiency, as well as some interesting announcements regarding costs. So maybe you can comment on OPEX and other ramp-up capital expenditures based on your fab solution.
Of course, we believe that there will not be one single technology like crystalline in the future. There will be space for others, especially as you mentioned in the hot region like India, where you have some advantages with thin-film technology. And we strongly believe that the final game will be the cost per watt. And if we have an advantage in that, it's probably not on the efficiency, it's probably less efficiency, but if you calculate then the manufacturing cost per watt, and especially also the levelized cost of energy, we see there still a big potential compared to other technology. And therefore we mention also many times that we see the thin-film silicon more as a second generation of solar technologies, not a rooftop application, it's more like a field application. And if I compare the progress from thin-film silicon in the last years, comparable to First Solar or so on, in the efficiency curve, we made bigger progress, of course, it's absolutely true, we started lower, but we see there a kind of good future. I would like to mention something regarding the capacity which you discussed before, because I'm coming also from another field like optical disc, and I also saw there similar behavior that you at the beginning you have probably 10 companies, entrepreneurs company, then 5 years later you have maybe 40 companies having 80% of the market, and then 5 years later you would have again 10, and I see similar behavior. There is just one problem. I mean, we discussed before about the 25% equipment which is not competitive anymore. However, they will not disappear, unfortunately, because if a company goes bankrupt and write off those equipment, you can be sure that someone will enter again in the game, and this is a little bit a problem in such kind of industry. Maybe we should think about machines which disappear after 5 years from themselves, but disposable machines. But if you look on the disadvantage, maybe you have maybe 10% higher cost, but if you look on the investment, which is probably in some cases maybe some dollars or some $100 because you take over the machines from a Chapter 11 company, we have to be aware that those still existing. However, at the end, I still believe there will be 5, 6 big companies in the market, unfortunately, or mainly Chinese, I guess.
That's interesting because we see so many producers. Peter, how's Central German advising smaller manufacturers, and how I can help them to ramp? And this is first question. Second question, let's expect a price of poly $30 to $35 per kilogram. What is the bottom line you see in the crystalline production based on up-to-date equipment?
So perhaps starting with your second question. So if you look at the development and the cost reduction in polysilicon making, and if I look at our product roadmap, and as you know, we are setting up polysilicon factories, providing technology. So we have now developed this advanced second generation polysilicon technology, and there I see a cost potential of, I would say, below $25 per kilogram is doable. And we also started in a new silicon technology. It's based on purifying metallurgical silicon more carefully and integrated it into the traditional polysilicon route. If you have that one, I think you have $2 to $3 more in cost reduction. And if you fully switch over to upgraded metallurgical silicon, which is known from the past, and then I would assess that we can go down below $15 per kilogram. So that is a little bit the potential I see in silicon production. And what you also have to take into account that also in silicon production a change appears, because now more and more people are integrating from quartz into polysilicon making, and that will also give a further reduction of the cost. So there's a lot of potential, and also keep in mind that the solar wafer will change. Currently we have mono and multi, but now there's a new material which is coming up, it's called mono-like. It's a mixture between mono and multi, and that material seems to spread out in the middle between mono and multi. And we checked our latest advanced technology, and with that type of mono-multi we got efficiencies of 19%. And if you make the total cost of ownership, including balance of system cost using that material, we found out that there's a certain cost advantage. So that means that the industry, if this is really true, that this new type of wafer material comes, also the raw material industry, the polysilicon industry will have to adjust their product portfolio accordingly. And that will shape the raw material industry if this really comes true, that this material comes into this industry aggressively. And if you look at the new players, that was your question. I just want to give one example. We had one company 1.5 years ago. There we had big players with 500 megawatt with 1 gigawatt capacity, and this company came to say we want to set up a 100 megawatt factory. And everybody is saying how stupid they can be. In this industry, everybody is growing. When the factory is ready, we will have 1.5 gigawatt factories. How 100 megawatt factory can compete with such big players? And then we did this job together with the customer, and their key target was very high product quality, but at very aggressive low cost. And what we found out is, even with 100 megawatt size, they could beat in cost per watt peak, because the efficiency was quite high. They could beat big players in the range beyond 500 megawatt. So even today, there's an opportunities for smaller players if you are really sharp and focusing and focusing on production cost and product quality. You have even a chance in this industry, I'm very sure.
Thanks for these views. Just a quick last question. Bringing all together this potential leverage within the building industry and updated equipment, bringing more efficiency, where do you see from today's perspective bottom line module-wise pricing for poly panels?
You mean the total cost of ownership for finished crystalline silicon module? There, I would say we have assessed that, and we came out in the year 2013. Good cost players, they can make crystalline silicon panels, I would say, in the range between 60 to 63 euro cent per watt peak. If you look 1 year further, then even we can go below 60 euro cent per watt peak. On the other side, there's one trend which makes me a little bit afraid, is the material. Because we analyzed in the county, the material share of the cost is 68%. And as we know, raw material prices, silver, copper, and so on, is going up. Energy is going up. Petrochemical products, the prices are going up. That is a trend which was not so much taken so far by the industry. I always advocate that the past years it was a time of technology providers and setting up big capacities. I think now the fight with the material providers comes. So the next 3 years we have to find new solutions to save material.
Hopefully many poly fabs are rampant, because this will take also 2 to 3 years to hit these timelines, right? Charlie, you made some deep insights, or gave us some deep insights regarding the new drivers for the PV world. You mentioned that earlier in that panel. What we see here is a quick analysis about levelized cost of electricity and grid parity. We have all heard about that and discussed that, and we see that hitting LCOE of 8 euro cents means that we have a target system price in southwest US of 1,470 euros. We have a system price in Germany with better environmental conditions, less environmental conditions of 840, and in India 1,365. So I think this is exactly matching what you meant, because we see that there are different areas for different technologies in the world. Of course, we'll see this shift due to fade out of feed-in tariff markets, more focusing on markets mainly in the Sun Belt region of this world. Unfortunately, these are all emerging markets. We have to educate the people there. Maybe you can share how closely you are working with your customers to explore these markets. We had in the morning the statement that the equipment manufacturers should bring down their cost as well to contribute to achieving such system prices. So I would like to ask you, what is your view reflecting your dialogue with the market?
Sure. First, the depreciation cost, the equipment contribution to the cost per watt is a small fraction. It's on the order of 10% or less. So modest changes or even substantial changes in equipment pricing has little bearing on what's really needed here. What's really needed here, I think, carries two dimensions. One, having a roadmap for the technology that helps everybody work towards the opportunities to reduce the cost. And I think the industry has come a long way in that regard. I think this year, the words that I use to talk to my parent organization from the integrated circuit world is PV met its CMOS moment. When the integrated circuit world converged on an architecture of CMOS, everything lined up. Industry roadmaps converged, focused R&D spending was directed towards how to continue to drive down costs. This year, crystalline silicon met its CMOS moment. Today, we're at a cost structure where there's $1 per watt or less of manufacturing cost to make a module that's about 14.5% efficient. I expect that it's easily doable within the next 12 months for that to come down to about 75 cents a watt and 16% efficient. And as Peter says, I think it'll be even more aggressive than that reference point, less than 60 US cents a watt and 20% efficient as we get the thickness of the silicon down. So the first thing that we work on with our customers is the roadmap for the technology. But more importantly, what we work on with our customers is the roadmap in the marketplace. So to understand where solar can be used and at what time and in what sequence. It's easy to take this levelized cost of electricity model and combine it with the learning curve for solar, that classic line that we reference for every cumulative doubling of the installed manufacturing base cost to come down by 20%. It's actually accelerating in the last several years as a result of innovation, an enormous pace of innovation. So we can model over the next decade this transformation for the world that by the end of this decade, within the next 9 years, we will see over 99% of the world being competitive in residential electricity with PV. How to reach those markets is part of the dialogue. Most of the customers I speak with, when we ask them about their view of the market, it's feed-in tariff, feed-in tariff, feed-in tariff. And the market is much more dimensional. There are huge opportunities existing today. So our approach in this is to make a win-win. If our customers can reach the market, they can grow. If they can grow, we can grow. So the way that we approach our customers is actually in building out a model for how to expand the market adoption of PV in the coming decade. And the transformation that occurs in this decade is something we have to plan for now, because it takes time for this kind of a sea change of perception to be realized by utilities and by governments around the world. Most of the audience we want to reach is not sitting in this room. This room is already been converted. The audience that we need to reach are the planners and the utility stakeholders to understand what to do with this technology that is directly cost competitive today with combined cycle gas turbines, which is the lowest cost way to get electricity additions. Looking at levelized cost of electricity is actually not how a utility thinks about solar or thinks about any generating capacity. They think about marginal cost. How much do I have to spend to get a few more watts online? How fast can I do that? How fast can I get a cash flow from that? Nothing is faster than PV. Nothing. Put in a module, you get electricity, you charge for it. Takes no time. So our ability to communicate to the utilities the advantages of marginal costs being realized in the most cost-effective way with PV, and being able to offset the capital risk of escalation in construction costs and permitting costs that extend out over a long period of time, uncertainty. Uncertainty after having committed capital, when do I get that first electron? We don't have to wait. So our approach to the customer is help understand the market, help understand the appropriate model for where PV can meet the needs of the growing need for electricity, and then understand the roadmap of the technology, and then how our equipment can support that roadmap to support the customer to expand their market.
I'm very happy, Charlie, that you mentioned that. That's exactly what was kind of missing link, and I'm happy that the equipment manufacturers are grabbing more downstream know-how, really to provide value to their customers and to consult their customers and to provide them individual solutions. And I think really this is one keystone to success. Peter Meyer-Burger, after exploitation of economies of scale, what are the future drivers for cost reduction in regard of increasing conversion efficiencies, enhancements in manufacturing processes, maybe in other components like inverters or BOS?
Yeah, in general, for me, I can follow what Charlie says. On one hand, we have to open the market now. We do not have to think in feed-in tariffs, go for it, and then we have the scale effect. And I think this is the fastest way to reduce the cost, to go for the volume and bring new innovative products in, but it is related direct to the demand in the market. A period like we are in now blocks innovation because companies, they don't have money to invest in, let's say, unknown technologies. They manage the R&D capex quite heavily, and so do our customer at the moment, because everybody is worried about the future, if it is solar or if it is automotive or whatever. It blocks everything. But to reduce furthermore, we heard already several activities, so do we find new technologies to drive the efficiency up. Going for system-driven thinking, it means high volume production. This drives the cost down, and at the end, it is a matter of acceptance, the existing costs. And for sure, today it is a big discussion about cost per watt peak. But as we already heard, we are already in a zone where we talk about the so-called grid parity. It is today really only the matter of how can we go for the volume in the market, because as said, the market is here and it should become a commodity. If you build a house, then you should also have your energy, and for sure also your energy storage in your house, in your building, or in your environment. And saying this, again, it's a matter of volume, and volume always drives the cost down. That we learned from several industries, and then the wheel turns forward and not backwards.
Thanks, Peter. It's for sure that there will be strong growth regarding new installed capacity in this industry. The industry will recover from this slight dip. Dieter, I know you have to vanish because you have your own CIGS forum. I would like to ask you just a final sentence regarding CIGS fab solutions. What is the level to bring a reduction in cost, and what are the advantages of this CIGS fab solution? And maybe you can also comment on TCO-wise total cost of ownership. What is your target roadmap?
So maybe just let me comment a little bit about it. Major difference of crystalline technology and thin film is, of course, thin film is a totally different way how you make the absorbing material. So this is a very thin layer in thin film. That means there's very low material cost what we have compared to the other technologies. But on the other hand, the biggest part of the overall cost today is still the equipment cost and the depreciation what we have. And this is actually the big potential of the thin film. Of course, this is also what we learned as we are in the LCD industry since 15 years, that there is a lot of room in cost reduction by scaling up equipment, by making bigger substrates, by having bigger factories, and this is exactly what we're doing right now. So we are designing much bigger tools, we are designing much more efficient vacuum equipment to make the real high efficient absorber material, and this is why CIGS has a major advantage, as the material itself is the highest potential. So this is definitely our roadmap that we followed, and we have really good success as we reached already the 14% efficiency this year, and this will be definitely going on. We have much higher efficiencies in mind for the next couple of years in CIGS, and we see there is a high potential to do it. And we see that the CIGS technology is a lot of room for cost reduction, because this is still a very young industry compared to what we have in crystalline. It's a very young technology. Especially in equipment, there is a big lack of standardization of machines. Almost all CIGS factories in the world today are using more or less custom-made equipment that have a lot of engineering cost in it. So if you can really manage to make here standardized tools, make them in really high volumes, so then the biggest cost driver, depreciation costs, are going down a lot. And this will open a very big potential for Synfilm and especially for CIGS. So from our cost calculation, we have total cost of ownership of about 50 euro-cent today. If you start in about 200 megawatt size, the CIGS factory, and we see a lot of improvement for further reduction in the overall cost. As I said, there's a lot of room in the depreciation, but also in the material. As glass is a major cost component of the Synfilm module, there's a big potential there. So we have some very interesting discussions right now with customers and with players out of the glass industry for integrated lines. So this is, by the way, what the LCD industry is doing since many years. So all big LCD factories have an integrated glass manufacturing line. They do the glass on site. So this is also offering huge further potential in the Synfilm technology to really cut down costs to 0.4, even 0.3 euro cent per watt.
So if my understanding is right, there is a fab optimum at 200 megawatt.
No, I think it's more or less a fab minimum.
Fab minimum.
It's not an optimum. The optimum would be bigger.
Bigger. Okay. Thank you very much, and please take your time. I know you have to lead your next session over there. From Oerlikon's perspective, you mentioned the Indian market that is very favorable due to environmental conditions for micromorph and morph silicon product. Regarding what was the momentum of the real-life performance with regard to this LCOE calculation we have seen? Is Oerlikon more focusing local markets in the Sunny Belt regions, or what is your strategy to help the customers to run fabs within these emerging markets?
I know, of course, today, like Germany is the biggest market, and but we see the future. We should go there where the sun is really shining, right? And therefore, markets. I just came back from Saudi Arabia, and they have huge problems because from all the oil they produce, they use daily 30% for their own electricity to produce that. And the energy minister or the oil minister has to sell the barrel for $2.50 to the energy minister, and of course he could in the open market earn maybe $70 per barrel. And the energy is increasing, the demand is increasing, and they are a little bit concerned about that most of the capacity which they produce will be used for their own electricity production, and therefore such kind of country would be really very good for solar photovoltaic, especially for thin film because of the temperature coefficient. And I also think that India has really a big potential, as mentioned before. And US, of course, as we know, especially California and all these areas are very nice for the solar industry. And of course, finally there in those countries, also in China, the cost is the driver. And as we discussed before, you mentioned, some people mentioned here that we maybe will be 63 euro cents in the future with crystalline, but as we know, and Mr. Mans, as we discussed before, we are already at 40 cents with thin film technology. And this would be a big advantage. You have to understand that if we discuss today about below $1, this is mainly for new equipment, right? So it's an investment in new equipment, but crystalline is already a mature market, which we have several companies with several gigawatts. And there you cannot reduce the cost per system, there only you can reduce the cost by higher efficiency or less cost in the raw material. But those capacity which is existing today, it's actually the price per watt is given there, in my opinion.
Peter, I'm sure you would like to comment on the cost roadmaps of the two thin film technologies with 40 cents as well as 50 euro cent. So has the race of technology just begun? Do you see place for more technologies, or what is your view on thin film from your perspective?
As you know, we are setting up thin film CIGS thin film factories, but also fully integrated factories for crystalline silicon. So first of all, the race in technology always takes place. It's always the industry is always rushing and running for technology, new technology improvements. That's clear. If I look at thin film, I have to say, according to our own assessment, thin film has its place with a market share between 15 to 20%. And it will, there are some advantages in thin film. There might be some advantages in geographical regions, in specific climate conditions. There, thin film has an advantage. Also, some building integrated photovoltaics. We have flexible thin film technology, so for buildings which have not the statics, which are not as strong as typical German buildings, and you want to integrate photovoltaics on the roof, you can use flexible thin film foils to put it on the roof. So there are markets which are thin film markets. But according to our assessment, that's between 15 to 20%. If I look at thin film technology, which is the winner in the future, I have to say for me, crystalline silicon is rushing now for module efficiency 16%, 17%, soon we will get 18% module efficiency. If you know that the share of the module in the overall system cost is shrinking, then the relevance of high performance product is getting higher and higher and higher. And that is a little bit the drawback for a lower efficiency thin film technology. So our company is well aware of this effect and is also pushing very much high efficiency thin film technology. And so far we have to say that the most advanced in efficiency is CIGS. And I don't see how the others, cadmium telluride, amorphous silicon, amorphous microcrystalline silicon, they will survive. I don't know. We have to see. And for disruptive technologies, I don't say that the time is fully over, but I don't see that there's a big potential for completely new. We have seen solar panels which have been prepared on cylinders. We have seen, powder which was put onto the roof and which gave us solar electricity. I think those fancy stuff, this is gone. That is dead.
I definitely agree and share your view. Charlie and Peter, we run out of time, so I would like to ask you to give us in 2 sentences your outlook 2012 to 2015. What is happening with that industry in that period of time?
The industry is no longer about technology. The industry is about the market and the access to financing. And in this time period, we're going to see a transformation from subsidized markets to unsubsidized. And the innovation that happens will be in development of financing models that can be scaled, generally using existing models like ESCO agreements or leasing arrangements as the mechanism for scaling the business. So while we have a soft market forecast for the coming year or two, I expect this is going to actually accelerate by 2013 to 14.
On the basis, I follow Charlie completely, and I see also quite a tough 2012 ahead of us. But your initial question underlines that there's a lot of big players see that we have a long-term, very steep growth, and we have to achieve the market needs, as we just have heard. So in this respect, we have to prepare for a big growth with an exit scenario from feed-in tariffs, so that we are really in a competitive, fast-growing market, and the consolidation will happen the next 1 and 2 years, and then we have still a bright future in this industry, and a future which is in a complete other dynamics than we have seen it Thank you.
Thank you very much, Peter. Thank you very much, gentlemen, for your time and for this very interesting discussion. I would like to continue that for hours, but unfortunately we are running out of time. So thank you and enjoy the short conference. Bye-bye.